Okay, so we'll start with the pseudocode today. Okay. So what is the algorithm? Here's a friend. Step by step of this. Okay, and yourself. What will look at? That's what first one. Pictorial representation of what? Algorithm. Pictorial representation of algorithm. Thank you. Thank you. So there is something called pseudocode. This somewhat equal program, but it doesn't follow the strict syntax. Okay. So whatever we have in the mind, that if we write in a rough way, okay. Program, but you're not sure about the syntax, or you don't care about the syntax anymore. You just want to know the steps. These are the possible steps I'm going to do. But you're not interested in doing all of them using plain English. Nor also you're not interested in drawing the flowchart also. But in some symbolic way, in a very short way, you would like to design the logic of your program. So that's what pseudocode is, right? Pseudo means imitate, right? Your pseudocode imitates the actual instruction. Your actual program. Okay, so whatever the program will do, the pseudocode imitate. Okay, but you have to execute the pseudocode. Pseudocode is just the logical idea that we have in mind, but that took shape in the node, right? So we call this pseudocode as a design tool. Okay, also a design language, program design language, because once you are done with all the basic things, you just look the step and then you apply the syntax, programming syntax. That's it. Okay. You're able to come up with the correct sequence of statements in pseudocode, and just merely copying them in a program with the right syntax will do good. That's all. Okay. So there are a few guidelines for writing the pseudocode. The first thing is the steps should be very clear and understandable, right? So everyone has a way of writing things, but the pseudocode is not only for you, but for your fellow programmers. So make sure that pseudocode is exactly understandable. Fine. And there are no strict syntax for the pseudocode, but there are certain recommendations like capitalizing the keywords so that we can clearly find a distinction between keywords used in the actual variables, etc. Right? And use indentation, okay, spacing. Use clear spacing to show the hierarchy. Okay, and multiple line structure should be properly closed. Okay, there should be conditional statements, okay, looping statements. So all those things we should ensure that it is within a particular block. Okay, this set of statements are within this block. So indentation will help you that, and the end statement that will make sure that here where the block ends, here the loop ends, here the condition ends. Okay, in program we won't do it. In pseudocode we will mark the beginning and the end of a loop or conditions. Okay, so these are the recommendations. Okay, there is no strict rule to write a pseudocode. Okay, but these recommendations, if you follow, then your pseudocode will look good. Okay, so some of the common keywords. I think some of the keywords we have seen in the chat also, but these are the keywords you can use. But it is not limited. You can use any more any other keywords also. But the keywords should represent the exact meaning of getting an input or output or computation, right? For working with inputs, you can use keywords like read, input, obtain, get, so on. Okay, for outputs, you can use print, output, display, show, fine. For computing, you can use compute, calculate, determine. For initialization, you can use set or in it. So in the flowchart, we have seen where you saw initialization. What does the initialization means? Yeah. What is the initialization? Yes. Yes. Exactly. Count equal to 0. That's what initialization is. Okay. You are initializing the count. Okay. Future can take many shapes. Count can contain many values. But initially, what should be there in the count? So every morning you wake up, you drink a cup of water, right? Initially the body, right? Many of you have this practice. Some of you might drink water and you drink sugar. So later on, it will be filled with so many things. So that's what initialization. First time you are assigned something to a variable. That's what initialization. Okay. Remember, initialization is first time. Okay, first time you assign a value to a variable, that's called initialization. Okay, or definition, they'll call something like that. Okay. Incrementing, you can use the keyword increment. If you are decrementing means incrementing over increase by default, it increases the variable with 1. Decrement abdina, it reduces a variable by 1. Okay. What if you want to increase it by 2? Yes, that we have to write it. Increment num by 2, like that we have to write. Okay. Or if you write increment num, it means what? You're expected num to get increased by 1. Okay, always by default by 1. So like what we have seen for flowchart and algorithms, pseudocode also follow the same design structure like sequence, selection, and loop control structure. So we know what sequence is, right? A series of statements executed one after the other. That's what sequence is. So only a right set of sequence will get you a solution, right? If you just alter the sequence, sometimes it will give you that's statement. See if you again, it should be.